In this video, we're going to talk about graphing linear inequalities. To do that, we're going to discuss a review of linear equations. We're going to review solutions to linear equations. Then we're going to talk specifically about graphing linear inequalities, and we'll wrap up with solutions to linear inequalities and what they look like. So just to get started, let's review linear equations. Here's a line. What's the equation of this line? Using y equals mx plus b, and we know that the slope is the m and the y-intercept is the b, we should be able to construct the equation for the line. So the slope is the rise over the run, and we need to pick 2 points, and those 2 points we can then count between them the rise over the run. How far do we go up or down, divided by how far we go over. And we do that in this case, the rise and the run are shown there. And actually, to get from the top point to the lower point, we have to go down 2, which is a negative 2, and to the right 1, which is a positive 1. So negative 2 divided by 1 is the rise over the run, and the slope is therefore 2. So far so good, right? So now we need to find out we'll write the negative 2 in place of the m. So we now have y equals negative 2x plus b. All we need is to know is where the y-intercept is. Well, the y-intercept is the point where the red line crosses the y-axis. And there you go. It's at 1. So the equation for this line should be y equals negative 2x plus 1. Now, next topic is reviewing what are the solutions to linear equations. So in a linear equation, like this one, all of the points shown here are solutions to the linear equation. That means if you take the xy coordinates from any of these points and plug them in for x and y here, you will get a true statement. You will find that they do indeed add up so that y equals negative 2 times the x coordinate plus 1. In fact, any point on that line is a solution to the equation. So what are the solutions to a linear equation? Well, we just mentioned it, but take a look at it this way. If we look at our old, early use of a single variable, you have x plus 3 equals 5, and you solve for x. Your solution is that x equals 2, which means that if you plug in 2 in place of x, you will get a true statement that 2 plus 3 does equal 5. Okay? Now, when we do this with 2 variables, if you have an equation with 2 variables, the solutions will contain a number for x and a number for y. So in this equation, in any linear equation, any pair of numbers x, y that makes this equation true is a solution to the equation. The ordered pair can be plotted on the coordinate plane. Sorry, the coordinate plane got cut off there. In addition, when you plot all the solutions to y equals negative 2x plus 1, you will see a straight line. Conversely, any ordered pair on the line is a solution to the linear equation. And of course, any ordered pair that is not on the line is not a solution to the linear equation. That's how solutions to linear equations work. Our next segment of this video is graphing linear inequalities. What do we actually do when we graph them? Well, we're going to continue on, starting with the line that we just drew, y equals negative 2x plus 1. We already know that if we select any x value, like this one, x equals 2, there is a corresponding y value that made into an ordered pair with x is going to be on the red line. In this case, it's 2, negative 3. So what does the shaded area show? Well, the shaded area shows all the y values that are less than negative 2x plus 1. Let me show you that in a little more detail. Here are 3 points. The orange point on the x-axis, the yellow point somewhere in the green area, and the red point on the line. All of these points have an x equals negative 1 as the ordered pair. So this would be negative 1, 0, negative 1, 2, and negative 1, 3. All right? The red point, so if you look at these 3 points, The red point is on the line, the yellow point is in the green shaded area, and the orange point is x equals -1, also in the green shaded area. So the red point is the xy pair for x equals -1, and that's going to be -1, 3. That's the ordered pair. The yellow point also has an x coordinate of -1, but the y value is 2. Once again, I apologize, the text is missing at the bottom there, but the y value is 2. So the y value for y equals -2x plus 1 is 3. The y value for the yellow point is 2. And I think you can agree that 2 is less than 3. So in this case, y is less than or equal to -2x plus 1. So the green shaded area is all the ordered pairs that have y value of less than -2x plus 1. Now remember, the shading goes on forever, and solid lines with shading indicate the following inequalities. So here's your solid red line, and this is a solid black line here. They indicate the following inequalities. The solid red line is, and the shading below is y is less than the expression. So in our case, it's y is less than or equal to -2x plus 1. Similarly here, since it's shaded above, it will be greater than or equal to -2x plus 1. Now there is another variation. If the line is dashed, sometimes we will draw a dashed line, it's because we're saying that y is not equal to -2x plus 1. It is actually everything that is below or everything that is above. It's either less than the expression or greater than the expression. But in this case, it is not equal to, because it does not have a line under the less than or a line under the greater than. So now we're in our fourth step, solutions to linear inequalities. Well, solutions of linear inequalities are like this. Here you see our two lines which are solid. If the line is solid, any ordered pair on the line or in the shaded area is a solution to the inequality. If the line is dashed, only the ordered pairs in the shaded region are solutions. So you could identify any ordered pair in the shaded area on the bottom graph, and that would be a solution, but not ones on the line in the bottom graph. And the upper graphs, yes, it could be on the line or above, or on the line or less than. In this video, you saw how linear inequalities are graphed and how to identify solutions from a graph. In a separate video, we'll see how systems of linear inequalities are graphed. Please follow my channel and leave your comments below.